The paper begins by discussing the work of Augustin-Louis Cauchy, a French mathematician who developed the concept of a limit. Then argues that Cauchy's definition of a limit is problematic because it relies on the concept of infinitesimals, which are quantities that are smaller than any real number. Then argues that infinitesimals are not well-defined mathematical objects, and that their use leads to paradoxes. Then goes on to discuss the Heisenberg uncertainty principle, which states that it is impossible to simultaneously measure the position and momentum of a particle with perfect accuracy. Majhi argues that the Heisenberg uncertainty principle can be explained by the fact that space and time are not continuous, but rather quantized. He argues that the smallest unit of space and time is the Planck length, which is about 10⁻35 meters. Then argues that the Planck length is the fundamental unit of reality, and that it is the smallest unit that can be meaningfully measured. He argues that this means that it is impossible to measure the position and momentum of a particle with perfect accuracy, because the uncertainty in the measurement of one quantity will always be greater than or equal to the Planck length. Then concludes by arguing that the Heisenberg uncertainty principle has implications for the study of quantum gravity. He argues that quantum gravity is a theory that attempts to unify general relativity, which describes the gravitational force, with quantum mechanics, which describes the behavior of matter and energy at the atomic and subatomic level. Then argues that the Heisenberg uncertainty principle makes it impossible to develop a consistent theory of quantum gravity, because the theory would require us to measure the position and momentum of gravitons, which are the quantum particles of gravity, with perfect accuracy.